This is the second video in a series created for 24houranswers.com to help students understand some of the basic concepts of physics a little bit better. Today I want to go over the ideas of problem solving. And it might seem like, why do we need to actually stop and talk about how to solve problems? I've been doing it for all of my life. Not like what you're going to be doing in physics. Problem solving in physics is very different from any other course, because what you're going to find is you're going to be given very limited information. You're going to be given no instructions as to how to use that information. You have to figure out where this information fits in the grand scheme of physics, what equations to use, how to put it all together, and then come up with a solution using math. So some steps right here that seem to help my students in the classroom. Step one. Always, always, always draw a picture. No matter what, it doesn't matter how terrible of a drawer you are, draw a picture. It helps you get an idea for what's going on. Step two, label that picture well. Label the fool out of it. Take everything that you find in the word problem, write it on the picture in the correct location. Step three, this one seems a little weird. Think about the physics. Here's what I mean by that. Actually, look at the problem and think, is this a mechanics problem? Is this a thermodynamics problem? Is this involving projectile motion? Now, all these words might not be familiar to you right now in the beginning of your physics course, but as we go further and further along, you'll start to recognize these and you can kind of categorize problems. 4, pick the equations needed. Maybe 1, maybe 2, maybe 3, depending on how complex the problem is. 5, plug in the values that you find from the problem that you labeled on the picture. Plug them into the equation or equations. 6, work the math. This is the easiest step of all. This is plug chug. You shouldn't focus any of your time here. It should just flow out quickly. The most difficult part of problem solving in physics has to be step 3, right there. Thinking about the physics of the problem, then leading to step 4, picking the correct equations. If you can get steps 3 and steps 4 down pat, everything else should be easy. So working the math, easiest step of all. 7, repeat steps 4 through 6 if it's a multi-part problem. So sometimes problems are very complex. You're going to take your answer from one equation or your solution that you got out of one equation and link that answer into another equation and then let you solve a little bit further, going for the final answer, the solution to the problem. 7, check and assign units to answers. 8, check and assign units to answers. Many teachers will instruct their students to actually work the units through in the equations. That's a great way to check your answer. If you're not doing that, please remember at the end of the problem to look back and say, what units does this need? If it's a displacement answer, displacement equals whatever, please assign meters, the base unit. But look back at the problem. Make sure that the things you were plugging in were in base units too. 9, this is the part that students forget all the time, and as a teacher it drives me nuts. Check your answer and consider if it makes sense. I can't tell you how many times a student has submitted an answer to me for, let's say, how far the car went from the state of Georgia up to the state of New Jersey, and they'll tell me the car went 50 meters. 50 meters doesn't make sense. Georgia to New Jersey is a long ways away. Now, don't overthink it. If you come up with, let's say, 500 kilometers, which is actually a little on the short side there, but don't overthink it. 500 kilometers might be a reasonable answer. Double check your math to see if you made any mistakes, but don't worry about it too much if you're coming around in the ballpark. To demonstrate this idea of how to solve problems, let me talk for a little bit about constant velocity. It'll be one of the first things that you end up learning in your classroom. We've already been over the difference between velocity and speed. They're the same thing, except velocity, remember, has a direction. It's a vector. The equation for constant velocity, velocity equals displacement, and I'm going to use an S for displacement, divided by time. Change in how far you're going divided by how long it takes. Now, the units for velocity is meters per second, just reminding you of these things. The units for displacement, meters, and the units for time is seconds. Now those are the base units. You can still work this with other units in there. The equation still holds. Just make sure that your units match up. What I mean by that is if you have, let's say, a velocity in centimeters per second, your displacement better be in centimeters or you need to convert. All right, let's work a problem here to try to demonstrate this idea of problem solving. Read the problem. A rabbit hops towards a garden full of carrots at 5.5 meters per second. If the garden is 35 meters away, how long will it take the rabbit to reach the carrots? A habit that you might want to get into, especially whenever you're just starting out in physics, is actually underline all the values that you're going to have to use. So 5.5 meters per second, that's going to end up being a velocity. Check out the units, meters per second, how fast the rabbit is going. And here's your displacement. What we're using S for 35 meters, how far away it is. All right, our first step in problem solving is to draw a picture. So let's get ourselves a rabbit here, and remember I said it doesn't matter how terrible of a drawer you are, and I'm pretty terrible at that, and it just doesn't matter. The idea is to get the concepts down quickly to be able to visualize what's happening. So I have a rabbit over here, and I have a garden with a whole bunch of carrots in it. Okay, so let's just put a bunch of carrots in it over there. The garden is 35 meters away, and we know the rabbit is moving towards the garden at 5.5 meters per second. So there's step 1 and 2. I drew a picture and I labeled it, putting down all the values I found in the problem. Step 3 is to think about what's going on here. All right, I got a rabbit. I'm hopping towards the garden. I know a displacement, I know a velocity, and I'm looking for, here we go, how long means I'm looking for time. How long does it take to go somewhere? Time. This is a constant velocity problem. Now, whenever you're just starting out in physics, it's a little bit easier to figure out which thing to use or where to categorize it and which equations to use because you have a limited number. But as you go further and further along, by the end of the year, if your teacher is allowing you to keep an equation sheet, you're not going to have an equation sheet. You're probably going to have 2 or 3 equation sheets, and they're going to be covered with equations, and you got to figure out what needs to be used. Here, though, pretty simple. So let's write our equation down. Velocity equals displacement over time. All right, next up, I need to plug into the equation. All right, so my velocity is 5.5 meters per second. I know my displacement, it's 35 meters, and I'm looking for time. That's my unknown. Let me come over here on the left-hand side and show you another trick too. Lots of times it's good to create kind of a bank of variables to pull from before you start actually plugging in. And it's just rewriting what you've already written on the picture, but sometimes banks are easier to pull from. So my velocity, 5.5 meters per second. My displacement, 35 meters is how far he's going to go, and time is what I'm looking for. Okay, now I just need to work the algebra. Step 1 is going to be to multiply both sides by time. It cancels it out over here, and that gives me 5.5t equals 35. The next step will be to divide both sides by 5.5 to get t by itself. And I come out with t equaling 6.4. Now I need to assign units to this. Now check out our units up here. Meters per second, base unit for velocity. Meters for displacement. Notice, by the way, meters and meters, it matches up. So I'm going to use the base unit for time here, which is already given right there, seconds. 6.4 seconds, all right? Last step. I need to think about this answer right here. Does it make sense? Now, this is where we don't want to overthink, but we just want to look at it to see, is it in the ballpark? And yes, this is in the ballpark. It takes a rabbit about 6.4 seconds to hop just a little ways to a garden. That's reasonable. Things that would be unreasonable might be, oh, it takes the rabbit 5.5 hours to go 35 meters. Well, that doesn't make sense whenever the rabbit's hopping at a normal speed. Or it takes the rabbit 3.2 microseconds. That doesn't make sense either. Rabbits aren't blazing fast going towards this garden. So yes, this makes sense. I did my math correctly. Here's my answer. I circle it. I'm done with the problem. Now, I know this problem was pretty simple and it didn't really require all these steps, but I want you to get into the habit. I highly recommend get in the habit of going through the process no matter what, because there will be problems down the road that are a lot more complex. And if you will just start going through the process of problem solving, drawing a picture, figuring it out, labeling it well, picking equations that go with that, and start going down that path, problems that you don't exactly know how to solve in the beginning, you'll end up solving as you move down through kind of the problem solving steps. In the next video, we'll jump to constant acceleration and what that means and just deal with that on the basic ideas before we get fully into kinematics. Thank you for watching. I hope that it helps you solve some of the more complex problems that you're going to run up against. Remember to actually go through the process. And also remember, if you're having trouble on any problems, check out 24houranswers.com. They have tutors there that can help you, where you can sit down, have some live tutoring, or you can submit some homework help to actually see what they're doing and study that. Check out my next video here in a little bit.